Welcome to another 8th grade math lesson. Now, if we look at the power of 5's table, we can fill it out. So 5 cubed is 125, 5 squared is 25, and we did this in class today. 5 to the first power is 5. Now, if I'm trying to figure out what 5 to the 0 power is, then what I can do is I can establish a pattern here. And what I meant to write is that this is evaluated, 125, 25, and 5. 5 cubed means that it's 5 times 5 times 5. 5 squared is 5 times 5. And 5 to the first power is just 5. So what I can do is, if I'm trying to figure out what 5 to the 0 power is, notice that's different than saying 5 times 0. 5 times 0 is 0, but that's not what 5 times 0 does not equal 5 to the 0 power. All right, those two are not the same thing. So to figure out what 5 to the 0 power is, we can just look at the pattern that we've established here. So here we have 3 5s, here we have 2 5s, here we have 1 5. Another way of saying it is that every time you drop down 1, you are reducing the factors, or you're dividing by 5. So 5 times 5 times 5 divided by 5 would just get you 2 5s here. 5 times 5 divided by 5 would get you 1 5. You can see it here too. 125 divided by 5 is 25. 25 divided by 5 is 5. So continuing on this pattern, 5 divided by 5 is 1. Okay, so this has got to be 1. All right. Now here, if I drop down again, so remember the pattern is established as we're dividing by 5. Well, 1 divided by 5, I can write that as a fraction. It's 1/5. Right? And 1/5 divided by 5 ends up getting 1 over 25. Okay? And 1 over 25 divided by 5 is going to get you 1 over 125. So if you look at the patterns that have been established here, 5 to the third power and 5 to the negative third power have a relationship. Look at what we have here. This is 125 versus 25. Okay? And you can also see the pattern established with 5 to the negative second power, which is 1 over 25, and 5 to the second power, which is 25, right? So the relationship is that they are reciprocals of each other, right? And again, likewise with 5 and 1/5, and it mirrors itself around 5 to the 0 power, okay? So 5 to the first is a reciprocal of 5 to the negative first, and likewise, they're reciprocals of each other, okay? So we get to our rules here. So right now, the zero exponent property says that for all real numbers a not equal to 0, so one of the restrictions is that the base can't be equal to 0, okay? That anything raised to the 0 power is going to be, this is actually 1. Anything to the 0 power is actually equal to 1. Okay, so 1,000,000 to the 0 power, let me just rewrite this. This is equal to 1. A to the 0 power is equal to 1. For the negative exponent property, what you do is you take, so if it's for all real numbers a and whole numbers b, so if you have a to a negative power, what you do is you make a unit fraction, you make it 1 over a to the positive power. Okay, just like we said that 5 to the negative third, 5 to the negative third was the same as 1 over 5 to the third, or 1 over 125. So you make a unit fraction. A unit fraction is with 1 in the numerator, and you put in the denominator, you put the same base, but you put the opposite of the exponent. Okay? So that's how you can deal with a negative exponent. Now notice that negative exponents, they don't act like we think they're going to act. They don't actually make 1/25 is not a negative number, but it is a very small number. This number is between 0 and 1 on the number line and pretty close to 0. It's pretty small, right? It's much smaller than a half, but it did not make it negative, which is what we often think is going to happen with a negative exponent. So let's talk about fractions raised to a negative power. Now, if you have this, if you have a fraction like a over b and it's raised to a negative c, so it's for all real numbers a and b and for whole numbers c, if you have a fraction like this, what's going to end up happening is you can evaluate, you can make the exponent positive by reciprocating the fraction, so flipping the fraction around and then putting it to the positive exponent here, right? So notice that you can either change a negative exponent into a positive one, or you can go from a fraction with a positive exponent back to a negative one, though we rarely go in that direction. We usually have, if we want a negative exponent, we usually want to rewrite it with a positive exponent. Okay? Okay, so we just learned a lot of new rules about exponents. Let's go ahead and try to use those rules for these examples here. So 9 to the negative 7. Now remember, that's the rule where if you have a to the negative b, you take 1 over a to the positive, raise it to the positive power. So let's just rewrite it. Let's just take it and try to, let's not evaluate what these would be. Let's just rewrite it with positive exponents. If you were going to do that, you'd make it a unit fraction, so you'd have 1 over 9, and you'd raise 9 to the positive 7 power. So that's it. I've taken this expression and I've made it, or this number right here, and I've raised it to the positive exponent, and I'm going to stop right there. Okay. What happens if you have a negative number as a base? Well, same thing happens. You take 1 over, okay, negative 6 is the base, so I'm going to keep the parentheses there that indicate that negative 6 is the base. And I'm going to raise it to the positive 10 power. All right? And I'm not going to try to evaluate it and get a number there. I'm just going to leave it like that. Okay? Now we have a fraction raised to a negative exponent. So I'm going to reciprocate the fraction as 4 over 5. Okay? It's a 4 right here. So 4 over 5. Once you reciprocate it, you take the opposite of the exponent like that. And again, I'm not going to try to evaluate it. This would be another fraction. So it would be 4 over 5 multiplied by itself 26 times. So let's evaluate some of these things using the rules that we have. Now here, again, the base is going to be the sum of these two things. So let's go ahead and evaluate that first. This would be negative 3 to the negative 2 power. Now I have a whole number, or I have an integer raised to the negative power. So what I'm going to do here is make it a unit fraction. So I'm going to make it a fraction with 1 in the numerator, right? So 1 in the numerator, and I'm going to put the base of negative 3. Notice I keep the parentheses there because this was my base. So this was like taking place of my a, right? I'm saying that a to the negative b is equal to 1 over a to the b. Now the thing that's my a here is my negative 3. So I have my negative 3. Instead of having it be to the negative 2, I'm going to raise it to the positive 2. Okay. Now let's actually go ahead and evaluate that. 1 over negative 3 quantity squared is going to be 1 over negative 3 times negative 3, which is 1 over 9. Okay. And so that is a combination of all the rules that we've used. All right, 8 plus 1/3 is going to be 8 1/3. Raised to the 0 power is just going to be 1. That's it. Okay, everything that's raised to the 0 power except 0 to the 0, that is not equal to 1. This is 0 to the 0 power is undefined. But anything else raised to the 0 power is going to get you 1. I actually didn't even need to do this sum. I know it's going to be 1, unless it got me 0. All right, so let's take this expression one at a time. The first thing I'm going to do is raise 2/5 to the negative 3rd power. So let me keep that negative 4 there. 2/5 to the negative 3rd. What I do is I reciprocate the fraction. Oops. Yeah, 5 over 2, so that's the reciprocal. And I'm going to rewrite it with the positive exponent. So I make two changes. I reciprocate and I take the opposite of the power. Okay, well, negative 4 times 5 to the 3rd, well, 5 over 2 to the 3rd just gets you 5 over 2 times 5 over 2 times 5 over 2. So this is negative 4 plus 5 times 5 times 5 is 125 over 2 times 2 times 2 is 8. And this is going to be, well, if we, let's see, negative 4, let's make it into something over 8. So multiply this by 8 over 8. So this was going to be negative 32 over 8 plus 125 over 8. So 125 minus 32, let's see, that's 3. I need to borrow, so that is not 12, I'll make it 11, so it's going to be 83, but it's going to be negative 80. Oh, no, actually it's going to be positive because this was more positive. So this will be 83/8. And you could change that into a mixed number, but the whole purpose of this exercise was to get rid of this positive exponent. So we are done in that regard. Okay, so make sure that you've taken careful notes on this part right here.